Hi, and welcome to the next video, which is going to be another probability rule, okay, which is going to be another formula for events that are not independent, okay? So let's talk about what it means to be independent. So you have an event A, okay, and you have an event B, okay? So when the outcomes in A do not affect the outcomes in B, then A and B are independent. So that's independent. So let's talk about things that aren't independent. So say we have 10 marbles. We have 10 marbles in a bag. Okay? And I'll say 1, 2, 3, 4, 5, 6. 6 of them are red, and 1, 2, 3, 4 of them are orange. Okay? So I'm going to say A is the A is the event of picking red, and B is the event of picking orange. Okay? So let's say I'm going to sample without replacement. Sample without replacement. That means I'm going to reach in here and pull one out, okay, and look at it. So once I reach this and I do this trial, okay, I pick a red. So now I take a red. Does that affect the outcome in B for the next pull? Yes. Okay, so I could give you an example. The probability of picking A, which is red, let me go to red. The probability I pick a red equals 6 out of 10, correct? Because there's 6 reds out of 10. 1, 2, 3, 4, 6, 1, 2, okay. Okay, but now one of them is gone. One of the reds is gone. So the next case, which is the probability of picking an orange, has been affected by what you did in A. So now the probability of picking a orange is 4 out of 9. Okay, because one of them's gone. Alright, so A and B are not independent. Are not independent. When events aren't independent, B, we call it conditional. B is conditional. This might not sound right. Conditional on A. Or B depends on what happens for A. So these are ways to show that A and B are not independent. So we have to come up with a formula for this. So to come up with a formula, let's look at the formula when they are independent. Okay, so the probability of A and B happening is the probability of A times the probability of B. Remember, we multiply. Okay, so this is when A and B are independent. So now let's look at this. The probability of A and B. Okay, so let's talk about this bag one. Was A affected at first? Was A affected when you had 6 reds? Was A changed? no A wasn't changed. So the probability of A stays the same. So it's the probability of A times, okay, same thing, which is, let me just change the color of this, probability of A, it's times the probability of B, okay, and this means now B is going to change because it depends on who? B dependent on whatever A happens. So it's B given, that means given A happened. Okay, so it's the probability that A happens times the probability that B happens given A happened. Okay, it's very, very important. So this is the formula when they are not independent. Okay, and this is sort of an example. So I'll give you another example. What's the probability that you pick 4 aces in a row? Okay, so just to let you know, there's only 4 aces in a deck. There's only 4 aces out of 52 cards. So I'm going to give you the definition. So I'm going to say A would be you pull an ace on the first pick. A is you pull an ace. Really, they're all you pull an ace. Just say this: C you pull an ace, and D you pull an ace. Okay, and I'm going to write this a little different, but this is going to look a little confusing, but the probability of it's really easy, but I just want to get you used to this notation. Okay, so that's going to be the probability that you pull an ace. Okay, so out of the 42, you picked 1 ace. 1 ace. Okay, so that's going to be, and I could write this probability. That's supposed to be a 52. So what's the probability? So what's the probability you pick an ace out of 52? That's 1, 4 out of 52. Okay? Does that make sense? Because there's 4 aces out of 52. Now the second, this is the second, this is the first, this is the second ace, this is the third, and this is the fourth. Okay? So the probability you pick the first ace, the probability you pick the second ace depends on if you pick the first ace, because how many do you need in a row? 4 in a row. So to get 4 in a row, the first one had to have been an ace. Okay, so this is the probability that the first one's an ace. So the second one, that's the probability that B happens given A already happened. Okay, so this is given A happened. So if A happened, what was picked on this first one? Okay, so an ace was picked on the first one. So how many aces are left? There's 3 aces left. And how many cards are left? There's 51 cards. Okay, so this is going to be times. So if there's 3 aces and 51 cards, it's 3 over 51. Okay, times the probability that C is the third ace. The probability that C happens given what had to happen already. This had to happen and this had to happen. So A happened and B happened. Okay? A happened and B happened. So if A happened, 1 ace is gone. I'm left with 51. If B happened, the second ace is picked. Okay? And I'm left with, I have 2 aces left. Okay? And I'm left with 50. Okay? So this would be 2 divided by 50. Okay, and times the probability that D, which is the fourth, that D is the fourth, but D given what 3 things had to happen already. The first ace must have been picked, the second ace must have been picked, and the third ace. So that's going to be A happened, and B happened, and C happened. Okay, so that's going to be, if there's 2 and 1 got picked, that means there's going to be 49 cards, and there will be 1 left. What's the chance that you pick this 1? Would be 1 over 49. If you put all this into your calculator, let me write this out. That would be 4 times 3 times 2 times 1 divided by 52 times 51 times 50 times 49. So put all that in your calculator, and that's the answer. Okay, so this is when they're not independent, and we bring in this thing called conditional probability. That's what the next video is going to be about. Conditional probability means the events are not independent. And you could use Venn diagrams, but we're going to use contingency tables. I found it's just a lot easier. Just use contingency tables when we're dealing with conditional probability. Okay, so thanks for watching, and have a nice day.